Hello, one and all present here. This is Amit Kumar Singh, and welcome to my class on volume and surface area of solid figures. So, I believe you have gone through all my previous videos based on mensuration, where I have talked a lot about lot of problems related to the mensurations. We shoot problems related to rectangles, squares, trapezium, rhombus, cone, cylinder, fructrum. More or less we have covered all the topics. I have made video dedicatedly where I talked very easy problems on mensuration. I talked about average or moderate level problems on mensuration. I talked about difficult level problems on mensuration. I believe you have gone through all my sessions, and now you are in that position that the moment you see the problem you can easily get the answer for the problem. But even then, because I'm not sure how many of you have seen my previous video. So what I'll do, I'll assume that you are beginner in the topic of volume and surface area of solid figure. So I'll talk primarily first giving introduction about geometrical figures, like when we talk about three-dimensional geometrical figures. So in volume and surface area of solid figures, we'll focus our discussion based on three-dimensional geometrical figures which have dimensions like length, breadth, and height. So here I'll talk the first geometrical figure which can come in my brain is cuboid. The first geometrical figure which can come in my brain is cuboid. So when I talk about cuboid, it has six faces. One face is like, when you talk about one face, so one face, it is like a rectangle. So when you talk cuboid, you have length, you have breadth, you have height, and the volume of by which you calculate the space which is covered by it, that is length into breadth into height. Now, one face, when you talk about face, it has six faces. So one face, if you want, like suppose if I talk about ceiling, the ceiling is top end. So if I talk about ceiling, so the area of that would be length into breadth. So like that, you have what you have base. Base is again length into breadth. Then you have four walls. Okay, they are either they are breadth into height or they are length into height. So like that, you can calculate. So when you talk about the area of four walls, if I talk about area of four walls, so the formula what we follow is 2h into L plus B. So this is the formula what we follow for area of four wall. For area of ceiling, you can use length into breadth. Okay, then probably if I talk about the surface area, the total surface area, if I talk about the total surface area, so the total surface area, that would be equal to 2 into length into breadth plus breadth into height plus length into height, because six surfaces are there. So this is cuboid, this is cuboid, this is basically a cuboid. Now when you talk about cube, in cube, length, breadth and height all are equal. So when you talk about cube, in case of cube, your length, breadth and height all are equal in case of cube. So we represent that, we call as edge. So like the side, all are equal, so we call them edge. So the volume of the cube, when you talk about cube, that is a cube. Then if I talk about the surface area, that is total surface area. So if I talk about the surface area of the cube, that is 6a square. Fine. And then probably the next thing is the diagonal. If I talk about the diagonal of the cube, that is root 3a. You can understand three-dimensionally. You can understand that is a three-dimensionally. Similarly, in the case of rectangle, if you want to know the diagonal, so if you want to know the diagonal of a rectangle, sorry, I'm saying rectangle, cuboid, three-dimensional rectangle is a cuboid, that is a root of L square plus B square plus H square. So whenever you're solving a problem, and in the problem, if you get something data where they're asking you the largest value, the largest dimension which can be fit into a three-dimensional room, that would be nothing but that would be equal to the rectangle of the given data. So you can see this question number 1. So a box 10 centimeter into 8 centimeter into 5 centimeter. What is the longest possible length a pencil can be fit on? So you need to find the diagonal. So that is under root of 10 square plus 8 square plus 5 square. So that is 10 is this is 64 plus 25 plus 100. So this is nothing but this is root of 189 you have to find. 189, when I talk about 189, so 189, if I talk about, this is 63, this is 21, this is 3, then this is 7. So if I see this, so 189, I can write this as 3 into root of 21. Okay. Then we understood this. So now you have knowledge about cuboid, you have knowledge about cube, so they are important for us to understand. Whenever we talk about a geometrical representation, we need to have a knowledge about them. So with them we can understand the basic concepts on cube and cuboid. Now going further, if you talk about cylinder, the volume of cylinder, so this is cylinder. If you talk about cylinder, so the volume of cylinder is pi r square h. While if I talk about the lateral surface area or the curved surface area for the cylinder, that is 2 pi r h. That is 2 pi r h. So that is 2 pi r h. So if I talk about cylinder, so imagine if I'm talking about cylinder. So if I'm talking about cylinder, so this is radius, you can see this is radius, this is height. So the volume of the cylinder, if I talk about the volume of cylinder is pi r square h, while the curved surface area or the lateral or curved surface area, so lateral surface area of a cylinder, that is equal to 2 pi rh, that is equal to 2 pi rh. While the total surface area, if you talk about the total surface area for a cylinder, so the total surface area of cylinder, for that you need to calculate both the ends. So this area, so this is 2 pi r square. Two circles are there at the periphery, at the top and bottom, plus curved surface area, that is 2 pi rh. So if you take 2 pi r common, so you will get r plus h. 2 pi r into r plus h. With that you will get the total surface area. Similarly, you can use a similar representation for you can use a similar representation for the cone. When we talk about cone, so this is cone, so the volume of cone is 1/3 of the volume of a cylinder. So this, for cone, this is radius, this is height, and this is called slant height. This is called slant height. This is called slant height, where when we talk of slant height, that is equal to a root of h square plus r square. That is called slant height. The volume, if I talk of volume, volume is 1/3 pi r square h. If I talk about the curved surface area, that is pi rl. So the curved surface area in the case of cone, that is equal to pi rl. While the total surface area, if I ask you, that is nothing but that is pi rl, which is a curved surface area, plus the area of the base, which is pi r square. So you can take pi r common, so that total surface area is pi r into l plus r. So you can understand this. Now we'll talk about more formulas like this. So let's try to see some numerical. Now you can see question number 2. What is the maximum number of pieces of 5 into 5 into 10 of cake that can be cut from this? It's very simple. So you just, if you want the maximum number of pieces of these all are in centimeter, so which you can cut from this. So again they are also, so max, for that you just need to find the original volume, which is your total volume, 5 into 30 into 30, and that if I divide by 5 into 5 into 10, so with this I can find the maximum number of pieces which I can derive from them. So you understand, individual piece is 250. The volume of individual piece is the volume of individual piece. The volume of individual piece is 250 centimeter cube. This is small piece, whatever the small piece, the volume is this much, while the total volume is 5 into 3 into 3 means 15 threes are 450, 4500, while the total volume was 4500 centimeter cube. So how many pieces you can derive from them? So you can derive total 18 pieces. Okay, then you can see the next problem. The sum of length plus breadth plus height of a cuboid is 19 centimeter and its diagonal is 5 root 5. So what is the surface area? So you can see the next question. So you can see the this question. Now you can see this question. So the sum of length plus breadth plus height. So the sum of length plus breadth plus height of a cuboid is 19 and its diagonal is 5 root 5 and its diagonal. So the diagonal is root of L square plus B square plus H square, that is 5 root 5. So L square plus B square plus H square, that is 25 into 5 means 125. Okay, so they're asking you the surface area. So you know the formula of surface area. Surface area formula is 2 into LB plus BH plus LH. So what you can do, you can apply the formula simple A plus B plus C whole square. So this will give you L square plus B square plus H square plus 2AB plus 2BC plus 2AC. So BH into LH. So this is given 19. 19 square is equal to, this is given to you 125, and this you need to find. This you need to find. So this is 19 square 361 minus 125. So this is 236. 236 divided by 2 means 118. Not 118, sorry. That is 2 we require to know. So this is 236 is equal to 2 of LB plus BH plus LH. This is the total surface area of this cuboid, 236. Okay. Now cylinder, already I talked about cylinder. So here they are talking about find the height of the cylinder whose volume is this much and the area of base is this much. So very easy problem. So you know the formula of cylinder, pi r square h. So this is pi r square is the area of base and h you have to find, and volume is given to you 511. This you just need to divide 36.5. This 511 divided by 36.5. So you get 5110 divided by 365. This is 1022 divided by 73. 1022 divided by 73. Now 73 ones are, and in 3 table 2 comes 4s are. So answer should be 14. You can check 14 into 73. 14 3s are 42. 14 7s are 98. So you can check that is 1022. Means that is answer correct. Fine. Now you can see the next question. Question number 5. A rectangular, this question came in UPSC 2002. A rectangular a sum, I don't know what is that, of dimension 6 into 5 into 4 is to build by using bricks to make the outer dimension 6 into 6.2. This, let me copy this. Now see this, a rectangular a sum of dimension 6 into 5 into 4. So 6 into 5 into 4, 6 into 5 into 4. That this is 6 into 5 into 4. So this is built by using bricks to make the outer dimension. So the outer dimension is 6.2. So this is 6.2. So 0.2, 6.2 means 0.1 both side. So 0.1 both side. So 0.1 both side. So 0.1 both side. Fine. So so it will become so 0.1 both side. So this, so when you see this, So this is 0.1 both side. So this is 0.1. This is 0.1. So this becomes 6.2. Fine. Now this height. So the height is also same. So this is 0.1, 0.1. So this was 4. This is 4. So this is 0.1. This is 0.1. So it becomes 4.2. Fine. And similarly, when you talk about breadth, so it is 0.5 both sides. So you understand. So the outer volume, is 6.2 into 5.2 into 4.2. Okay, and then the inner volume, when you talk about inner volume, so that is 6 into 5 into 2, 6 into 5 into 4. Okay, is built by using bricks to make 5. So how many bricks of size this much are required to bring a sum for storing water? So I believe the water will be stored will be in these places. So I think these are the places. That's why they gave you outer and inner dimension. So you need to find the volume of that is some that is three-dimensional representation. What you can understand from this, and that would be that volume of that would be the empty space between the outer boundary and the inner boundary. What you can understand. So I can say that the volume of that is some whatever is there. So volume of that is nothing but 6.2 into 5.2 into 4.2 minus 6 into 5 into 4. So what is 6.2 into 5.2 into 4.2? So we can do it very fast. So 62 into 52. This is 30. This is 12 plus 10, 22. This is 4. This would be 3224. This is Vedic maths. So already I explained Vedic maths in my videos. I have made around 8 videos on Vedic maths. So you can go through them. So 4, 4, 6. Then this is 16, 1 carry, 9. This is 8, this is 12. So this is 8, 10, 14, 15, 135408. Then 3 decimal. So 135.408 minus this is 30 into 4 120. So this is 15.408. So this is the volume 15.408. You can see the unit. So all unit are in meter. So you can see. So this volume is 15.408 meter cube. So you can see that. Now so how many bricks of size, approximately how many bricks of size are 10 into how many bricks of size are 20 into 10 into 5 are required to build this for storing water. So this is the volume. And now how many bricks? So the number of bricks. Would be number of bricks. 1 minute. So now the number of bricks would be nothing but that is the volume of a sum, whatever is this, divide by the volume of one brick. That is the volume of one brick. But if you notice, the dimension of bricks are in centimeter, while this was in meter cube. So I believe everyone knows 1 meter is equal to 100 centimeters. So 1 meter cube is equal to 10 lakh centimeter cube. So this I can do this. So this is 15.408. If I convert this into centimeter cube, this divide by the volume of the brick. So the brick is 20 into 10 into 5. 20 into 10 into 5. 20 into 10 into 5. So 25 is 100. Then again, so this is 1000. This is 20 into 5 is 100 into 10. this is 1000. So this is 15.408 into 10 to the power 6 divided by 10 to the power 3. This is 15408. Now the next question you can see is sphere and the cube. They have the same surface area. So the ratio of the volume of sphere to the cube is sphere and the cube. They have the same surface area. So let's talk about sphere a little bit. So when you talk about sphere, it's a three-dimensional circle where the volume of the sphere is 4 by 3 pi r cube, while the total surface area of a sphere is 4 pi r square. This is called sphere. While the half of this is hemisphere. Called as hemisphere. So when I talk about hemisphere, this is hemisphere where the volume of this is 2 by 3 pi r cube. The curved surface area means, when I say curved surface area, I just see the boundary of them. The boundary of that is curved surface area. So if I talk about curved surface area, the curved surface area, that is equal to 2 pi r square. While if I talk about total surface area, so total surface area is curved surface area plus the area of base, that is pi r square. So that will be equal to 3 pi r square. So you can know that. Now next question is that here the sphere and the cube, they have same surface area. So when you talk about this sphere and the cube, the sphere, the surface area is 4 pi r square and cube surface area is 6a square. I'm assuming r is the radius of sphere and a is the edge of the cube. So I can say 2 pi r square is equal to 3a square. So what is the ratio of volume of sphere to the cube? They ask me the ratio of volume is 4 by 3 pi r cube divided by the volume of cube is a cube. So you need this value. So you need 4 pi r cube by 3 a cube. You need to find this. Now so I would have written this better. This would be 4 by 3. So this I can write, this is 2 by 3. This is 2 by 3 pi r. So 2 by 3 pi, 2 by 3 pi. This is a square by r square. Okay, so a square by r square is 2 by 3 pi. So I can write r by a. I can write r by a as the square root of 2 by 3 as a, that is the square root of 3 by 2 pi. This is the square root of r by a. So if you want r by a whole cube, so r by a whole cube, this is square. So this would be 3 by 2 pi, and this would be 3 by 2. So square root is 1 by 2. This is 3 by 2 times of 3 by root 2. Okay, so now if I want this value, now I need more space. One minute, let me create more space. So this you where to create space. So what they have given in the problem, that the sphere and the cube have same surface area. The sphere and the cube have the same surface area. So sphere and the cube have the same surface area, they're asking you the ratio. So they're asking you the volume of, they're asking you the volume ratio of volume of volume of sphere by the volume of cube. This is what they're asking you. They're asking you volume of sphere by the volume of cube. So I can say, that so r square by a square is 6 by 4 pi. Okay, so I can say r by a is 6 by 4 pi square root. So if I want the cube, so r cube by a cube is nothing but 6 by 4 pi to the power 3 by 2. To the power 3 by 2 means 6 by 4 pi into square root of 6 by 4 pi. 1 plus 1 by 2 is 3 by 2. So now, so this volume is sphere is 4 by 3 pi r cube into volume of cube is a cube. So this is 4 by 3 pi into, so r cube by a cube is 6 by 4 pi. This is 6 by 4 pi into square root of 6 by 4 pi into square root of 6 by 4 pi. So 4 pi get cancelled. This is 2 times. So this is 2 to 6 by 4 pi. So if I bring 2 inside, you get 6 by 4 pi into 4. You get the square root of 6 by pi. Okay, now see the next question. So if each side of cube is decreased by 19%, then what is the decrease in the surface area of cube? You know that the formula of surface area is 6a square. So in this formula, the 6 is constant, but the a changed by 2 times. So you can directly apply the formula, or if you're good with the concept of percentage, so you can directly apply the formula that x percent plus y percent plus xy by 100%. This is the formula for successive percentage change. So here decrease by 19 minus 19 minus into minus plus 19 square 361 by 100%. You will get minus 38 plus 3.61%. So if you do, you'll get minus 34.69%, minus 34.39%. If you do not understand this, no problem. So you can assume some number, and like suppose I assume that the edge is 100. Suppose I assume that the edge is 100 or 1. Suppose the edge is 1. Suppose the edge of the cube is 1. So the surface area of this, is 6a square. Now if the edge decreased by 19%, 19% means what? It becomes 0.81. So now the surface area will be 6a square, means 6 into 0.81 square. 0.81 square, 81 square, 6561. Become this much. So now how much your surface area decrease? So how much 6? That is 6 is constant now. So you can ignore surface area. So what is the percentage decrease in surface area? This is actually percentage problem. That is equal to 6 minus 6 into 0.6561 divided by 6 into 100. You can take 6 common and remove it. So 1 minus 0.6561 if you do. So how much you will get? So 1 minus 0.6561 if you do. So how much you'll get? That is 0.3439. 0.3439 into 100. If you do, you'll get 34.39%. Now read the question number 8, everyone. Now see the question number 8. This came in UPSC exam. So a rectangular piece of iron measuring 50 into 100 is rolled into a cylinder of height 50 centimeter. If the cost of painting the cylinder is rupees 50 per meter square, then what will be the cost of painting the outer surface of cylinder? Now see this. Now see this question. Now a rectangular piece of iron sheet measuring 50 into 100 is rolled to form a cylinder having the height 50, means it is like this. This was 50, this was 100. So you rolled it so that the height is 50. Means the circumference of this will be 100. The circumference will be 100. So the length of this rectangle become the circumference. So now so what they're asking, what is the cost of painting the outer surface? Means they are actually asking you to calculate 2 pi RH. So 2 pi r is 100, and they're asking to calculate the so they're asking you the outer surface means what? They're asking you to calculate the curved surface area. So the curved surface area, is nothing but that is 2 pi r into h. So means 2 pi r is 100 and h is 50. So this is the curved surface area meter square, where the cost is given 50 rupees per meter square. Okay, now they are in centimeter. Okay, fine. This is the catch. Now they are in centimeters. So here you got centimeter square. So this is 5,000 centimeter square. You know that 1 meter is equal to 100 centimeter. So 1 meter square would be 10 to the power 4 centimeter square. So this if I write in meter, this would be 0.5 meter square. And per meter square, the cost is 50 rupees. So the total cost would be, the cost of 0.5 meter square would be 0.5 into 50. So you will get 25 rupees. Per meter square cost is 50 rupees. Okay, so this cost would be 25 rupees. Fine. Now the next question, question number 9, a rectangular tank. You can see this question. Now you can see this question, a rectangular tank measuring 5 into 4.5 into 2.1 is dug in the center of field measuring 3.5 to 2.5. So this is the field 3.5 into 2.5. So this is the field. So in this field, what you are doing, you are creating a space, and with the dimension of the space is 5 into 4.5 into 2.1. The dimension this space is 5. This is 5 into 4.5. 5 into 4.5. So we are creating a cuboid like something like this. This is so this is 5 into 4.5. So the breadth. So the breadth is so this is 5 into 4.5 into 5 into 4.5 into 2.1. So you're creating a dig in this space. So when you're using this, if you see two dimensional, imagine I'm seeing two dimensionally. So the how much the area you occupied? So you occupied from the total 13.5 to 2.5. You have occupied the area 5 into 4.5 to create this. So with this, how much the area left? Because whatever the soil, whatever the earth material you get by digging, you will put on the remaining part. So whatever is your remaining area, so what is your remaining area? So your remaining area, so where you put the soil, so your remaining area is 13.5 into 2.5 minus 5 into 4.5. So on this remaining area, what you will do, you will put the soil, the soil what you create, what you get, the soil what you get, you put there, and because you put there the soil, so the height will increase. So that height what I'm calculating here, and that is equal to the this is equal to the volume created, the volume what you created. So this is equal to the volume what you created. The volume what you created is 5 into 4.5, 5 into 4.5 into 2.1, and so all are in meter and all, so there's no problem. The all in unit is in meter. So I can write 13.5 as 27 by 2 and 2.5 as 5 by 2 minus 4.5 as 9 by 2. This is 5 h. So this is equal to, this is 5 into 4.5. So that is 22.5. 5 into 4.5, 45 5s is 225. So 5 into, that is 22.5. This is 22.5 into 2.1. 5s are 25 to carry 22.5. So this will give you 27 5s are 35, 135 by 4. This is 135 by 4. 35 5 3 carry minus 45 by 2 into h my is equal to this is 225 225 into 21. This is 225 into 450 450. This is 25 and this is 7 4725. Then 2 decimal 47.25. 47.25 I can write 1 by 4. So into 4 means 28, 8 to carry 188, 189 by 4. 189 by 4. Here this LCM. So 135 minus 90. So 135 minus 90. 135 minus 19 is 45 only. 45 3 is 135. This is how much? This is 188 now. This is 8 to carry 189. 189 by 4. This get cancelled. So the value of h is 189 by 45. You can see the option options are in decimal or what. So here they are asking in decimal. 189. This is 45. So 45 fours are 180. 45 forza is 180. So this is 9. This is decimal. This is 2. 4.2. Okay. Then you can see the next question. Question number 10. Question number 10. You can see if the base radius and the height of a cone is doubled. So base. You know the cone formula 1 by 3. You know the formula 1 by 3 pi r square h. Suppose the radius is 1, height is 1. So if the radius, you double the radius 1 by 3 pi. So if you double the radius and the height also you double, divide by earlier they are 1 1. How much the volume will increase? The volume will increase by 8 times. Fine. Next question. The three cubes with side 3, 4 and 5 are melted to form single cube, and the diagonal of that is 12 root 3. So you know that the diagonal formula is root 3a. So you can understand if the diagonal of larger cube is 12 root 3. So the side of the diagonal, edge of the diagonal, sorry, the edge of the larger cube would be 12. I hope you can understand. So you understand. So if you, when you're putting like them, if you're putting them together, so ultimately, if you understand this, if you put them together, so three cubes, if you're melting them together, so the resultant cube volume would be the sum of volume of these cubes. And you know that the formula volume of cube is a cube. So 3 cube is 27, and 4 cube is 64, and 5 cube is 125. If you add them, 9 plus 7, 16, 1 carry, 6, 8, 10, 11, 216. So 216 x cube is 1728. Now 6 threes are 18. So this is threes are so 216. Then 6 table 8 also comes. So 216 8s are 48, 4 carry 12. It's 1728. Okay, so x cube is 8. So x is equal to 2. We got the x value 2. So the sides would be 6, 8, and 10. Because 3x, if x is 2, then 3x would be 6, 4x would be 8, and 5x would be 10. Okay, then capacity means they're asking you the volume, and here the options. Okay, so options can be in meter and all. If the options can be liter, so you know that 1 meter cube is equal to 1000 liter. They're asking you what is the capacity of beaker bucket, which is 45 centimeter high and the radius at the ends. Okay, so they are talking about fructrum. Here they are talking about fructrum. So here in this question, they are like, so suppose this is a fructrum. So the height of this fructrum is 45. The height of this fructrum is 45. Radius is 7, and so the radius is 7 and 28, and the height of this is 45. The height of this is 45. So if you talk about fructums, if you talk about fructrum, now if I one now if I talk about fructrum, so you should know the formula in fructrum. So the curved surface area of a fructrum is pi L r plus r, r capital R plus small r. That is the curved surface area of the fructrum. So that is pi L capital R plus small r, where L square is equal to h square plus r minus capital R minus small r square. Total surface area is the smaller the top areas, that is pi small r square, then the bottom pi capital R square, then pi L, that curved surface area, pi L plus R. The volume is 1 by 3 pi 1 by 3 pi h, then small r square plus capital R square plus r and r. So the volume is 1 by 3 pi h, that is r square plus small r square plus r into r. So 1 by 3 pi is 22 by 7, h is 45. So this is 28 square 784 plus 7 square 49 plus 28 sevens are 56 plus 5 14, and 5 is 196. So you can calculate this. So this is 15 into 22 by 7. So that is 784 plus 196. That is 10 carry. Then 9 plus 8 18 1 carry. So 9 980 plus 49. 980 plus 49 should be 1029, I guess. 1029. So this is 1za, then 32 4za, then 49. This is 147. This is 15 into 22 into 147. So 15 into 22 into 115 to 22 is 330 into 147. So 147 3za is 1 3za 14 1. 7 threes are 21, 2 carry, 12, 14, 1 carry, 3 plus 1, 4. So this is 144. So this is 518 48510. 48510. This is the volume. 48510. Then the next question, you can see question number 13. The height of a cone, you can see the height of the cone is 30 centimeter. A small cone is cut at the top by the plane parallel to the base. If the volume is 1 by 27th of the given cone, then the height of the smaller cone is. Now you can see the problem. So the height of this cone, is the height of the cone is 30 centimeter. The height is 30 centimeter. A small cone is cut. A small cone is cut. A small cone is uh, cut at the top by a plane parallel to the base. And if the volume is 1 by 27, the volume is 1 by 27, find the height of the smaller cone. So you can suppose this radius is R1, this is R2, and this is suppose H, because that is given 30, the bigger one. So the volume of smaller cone is 1 by 27th of 1 by 27th of volume of large cone. So you know this. So the volume of small cone, that is 1 by 3 pi, that is R2 square into H2, that is equal to 1 by 27 pi, 1 by 3 pi, then R1 square into 30. Okay, so I can cancel 1 by 3 pi, 1 by 3 pi, and then what I can say R2 square into H2 equal to 1 by 27 into 30 R1 square. So, so I can say this is R2 square into H2 is equal to 10 by 9 of R1 square. So this I can say, this relationship I'm getting. They're asking me this, no, height. This is 10 by 9 R1 square divided by R2 square. I can write, because ultimately I have to find the height of the smaller cone, that I have to find. Okay, and next thing, you know that they form a similar triangle. You know that they will form a similar triangle, like this is A, this is B, this is C, this is D, this is E. You know that triangle ABC that would be similar to triangle ADE. So with that you can say AB by AB by AB by AD will be equal to BC by DE. So you know that H2 by 30 will be equal to R2 by R1. You know this. Fine. So you know this relation. So you know this, that this height, this is equal to 30 into R2 by R1. You know this. This you know 30 into R2 by R1. So this is 30 into R2 by R1. So I can write in the term of R2 by R1 because I have to find the height. So this is R1 by R2. This I can write. So I can write R1 by R2 is equal to 30 by H2. Okay, so I can write R1 by R2 whole square is equal to 900 by H2 square. Fine. So in place of R1 by R2 square, I can write 900 by H2. So this H2 will be equal to 10 by 9 into 900 by H2 square, 900 by R1 by R2 square, 900 by H2 square, 900 by this is square, no, H2 square. This is H2 square. So I can write H2 cube is equal to 1000 So I can find the value of H2 is equal to 10 centimeter, assuming the height is given in centimeter. Now read this question number 14. Try to get the answer. Now you can see question number 14. If the weight of spherical cell is 7 by 8 of what it would be if it were a solid cell, then what is the ratio of inner to outer radius of the cell? So you can understand this. So if the weight of the spherical cell is 7 by 8 of the solid cell, so this is our capital R, and suppose this is small r. Fine. So if you talk about now the weight of spherical cell, imagine it's like somewhat kind of a ring kind of structure. So then the volume of that would be pi 4 by 3 pi r cube minus small r cube. Now if this would be a solid structure, then there not be small r on that. There's nothing ring and all. So then its volume would be 4 by 3 pi capital R cube, and this is 7 by 8. So you can cancel 4 by 3, 4 by 3 pi. So now they're asking you this ratio. No? You just need to solve it. So I can write 8 into capital R cube minus small r cube is equal to 7 r cube. So I can write 8 r cube minus 8 small r cube is equal to 7 capital R cube. So r cube is equal to 8 small r cube. So you can say r by small r. So the ratio of inner to outer radius. So inner to outer, they are asking me inner to outer means small r to capital R. So small r to capital R cube, the ratio is 1 by 8. So small r to capital R is equal to 1 by 2. Now this is the problem, easy problem. Now you can see question number 15, that a cylindrical vessel of radius 4 centimeter contain water, a solid sphere of radius 3 centimeters lowered into the water until it completely immersed. What is the level, rise in level? So it's very easy. So Archimedes principle, you can apply Archimedes principle. So you can apply Archimedes principle. So there's a cylinder. So the radius of the cylinder, I think, is 4. So the radius of the cylinder is 4, and then you're putting sphere of radius 3, 4 and 3. So the radius, this is 4, and its height is suppose h1, doesn't matter. Now because when you start putting sphere, the height increase, and it increase by h2, something like this. To understand this, whatever is the increase in height, that increase in height, whatever, suppose that is h2, whatever is the increase in height, that happened because of the sphere what you put. So that means so here, so 4 by 3 pi, the sphere radius is 3 cube, that is equal to pi r, that is 4 square into h. So here h2 whatever, so that increase in height, whenever you do this kind of problem, so that increase in height, h2 is that increase, okay, that increase in height is because of the volume what you have put there. So you can solve it. So pi you can cancel. So this 4 become 4, okay, and then this is 3 cube, so this become 3 square means 9, so that is h2. So the increase in height is 9 centimeter or whatever. So the level, no, something is mistake. Therefore, the solid vessel of radius 3 is lowered into the until, so okay, fine. So pi r square h. What is the calculation mistake? Pi, this is 3 square. Okay, this 4 was there. No, okay, sorry. This should be 9 by 4. This should be 9 by 4. Okay, fine. So now you can see the question number 16. A wooden box open at the top. So there's an open at the top. So if it open at top, so there's no ceiling. So if there's no ceiling, then there's no length into breadth at the top. At the top, there's no length into breadth. Okay, so if there's open at the top, if that is open at the top, so if you see this, if it open at the top, if you see this, if it open at the top, so the total surface area in that case would be, then the total surface area in that case would be L into B plus 2 into L into H plus 2 into B into H, because there's no, the face, that face, top ceiling face will not be there, okay, because that is empty. Okay, so the thickness is given to you 0.5 centimeter. So the length, that is inner length, is given, or is given 21 width and height. The expense of painting, what is the, so the length is 21. So the length is 21. So that inner length is 21 and the thickness is 0.5. So the outer length, outer length 0.5, 0.5 both sides. So that become 22. Outer breadth, so the outer breadth, so outer breadth, that is width is 11 and both side 0.5, 0.5, it become 12. The outer width will become 12, and outer height, and your outer height, that is given to you. Now that is given to you 6. Now you need to understand that that at the top, this that is empty, so there's no thickness at the top. And when you talk about height, so there not be upper layer on the height, you can understand. So there's not be upper layer on height, and only bottom there would be 0.5, but at the top there's no 0.5, because you can visualize, because that is empty. So the outer height would be 6.5. The outer height would be 6.5. So with this I can find the total surface area. So that would be 22 into 12 plus 2 into 22 into 6.5 plus 2 into 12 into 6.5. So with this I can get the total surface area. 22 into 12, 24 means 264. 24, that is 264. 264. So 6.5 I can write 13 by 2. So 2 get cancelled. So 13 into 22. means 26. 26 means 286. This is 286 plus again 6.5 is 13 by 2, 2 together. 13 into 12 is 156. So this is so this, if I add this would be 10, 14, 15, 1 carry. This is 550 plus 156. So this is 1 carry, no, 5, 6, 7. 706 meter square, centimeter square, I don't know. Whatever the unit, centimeter square. So the total surface area would be 706 centimeter square. Now the expense of the painting are 70 rupees. So the expense of the painting is 70 rupees. So the expense of the painting is 70 rupees. So you are paying total money 70 rupees. So the cost per meter, cost per centimeter square is suppose I don't know, A rupees. So for the total cost would be 706 into A rupees. Okay, so the total that is equal to 706 A is equal to 70 rupees. So the rate, what is the rate of painting per square centimeter? If you do this, so this is nothing but you have to find A is 70 by 706. So you can understand 70 by 706. What is your answer? Answer would be around 0.09 something. So this would be 706. So this is 70. You can see the option with that. You can understand this 700. So this is 700. So Banza also it will not go. So again you put 0. So this is, it will go by 9za, 0.09 something. So there's only one option which is close to that. That is 0.1. Okay. Now you can see question number 17. Now see the next question. Question number 17. So a right circular cone of height h is cut by the plane parallel to the base at the height h by 3 from the base. Then the volume of resulting cone and the fulcrum are in ratio. So now this is total is h. Now this is h by 3. This is h by 3. So this would be 2h by 3. So this would be 2h by 3. A, B, C, D, E. So you know that they will form similar triangle and all. So the ratio of radius and the ratio of height would be same. So if this is R1, this is R2. You can understand R1 by R2, they will be in same ratio. They would be in the same ratio, 2 by 3 ratio. You can understand, no? So because the that you cut h by 3 from the top, from the base, so that is 2h by 3. So this is 2h by 3 and this is h. So you can understand the same ratio will be of height also. So height also the same ratio. This is h1, this is h2. Suppose this is h1 and this is suppose h2. You can understand this. And so what they're asking you, they're asking you the volume of the resulting cone and the fulcrum are in ratio. So they're asking you the volume of the resulting cone. So resulting cone divided by the volume of fulcrum. The volume of the fulcrum. So the volume of fulcrum is nothing but that is original volume. So that is original volume. This is volume of smaller cone. So this is the volume of smaller cone, small cone. This is small cone divided by this is volume of spectrum is the volume of original cone minus the volume of smaller cone. So you understand this now? Now, now if you understand this, now if you then one more thing you need to understand that you know this that they are in ratio this 2:3. So the ratio of them, so they are the ratio is so the ratio of them is 2:3. So the ratio of the smaller cone with respect to the larger cone is 2:3. So the volume ratio will be 8:25. The area ratio would be 4:9. Okay, you understand this now? So ratio, if you understand if you talk with cone, so the what you say side or whatever. So the radius of small cone divide by the radius or height, all are in same ratio. So the radius of big cone, so their ratio is 2/3. So the volume of small cone divide by the volume of big cone, they will be in the ratio 2/3 whole cube, that is 8/27. You understand it? So the volume small cone is 8/27 of the volume of big cone. Okay, so just the volume small cone is suppose x. The volume of small cone, should I say volume of small cone? So suppose the volume of big cone is x. So the volume small cone is 8/27 of x. So this would be x minus 8/27 of x. So this is uh, so this is 8x/27. This is 27 minus 8. That would be 19x/27. The ratio would be 8:90. So if anyone have doubt on this and all, so if anyone have the doubt, you can prove this and all. The volume of height of small cone divided by the height of big cone. You can prove all this. So you know the formula 1/3 pi r square h. So you know that 1/3 pi, and you know that smaller cone, the radius is 2/3 and the height is 2/3. So if you calculate, this would be 8/27 only. Right? So you can easily calculate and you can easily understand this. Otherwise, this is the property of similar triangle. Anyway, so if you are good with triangles concept, you can easily understand. Otherwise, here also like this you can understand. Okay. Now the next thing, if the height, curve surface area, and the volume of the cone is given to you like this, and you need to find this value. Uh, so if the height, curve surface area, so height, curve surface area is what? Curve surface height is h, curve surface area of a, this is pi rl. So cone, that is pi r h square plus r square, that is c. And the volume is 1/3 pi r square h. Okay, and what you need to find, you need to find this 3 pi vh cube minus minus c square h square. So c 3 pi vh cube, 3 pi vh cube minus c square h square plus 9v square plus 9v square. Let's do this. So 3 pi v is 1/3 pi r square h into h cube minus c is pi r h square plus r square into h square plus 9v. V you know, then if I ask you v square, So if I ask you v square is what? Pi square r to the power 4 h square by 9, that is v square. So this is that is pi square r to the power 4 h square by 9. So now calculate this. So this and this get cancelled. So this is r square h to the power 4 minus this is this get cancelled. So this is pi r square plus r square, and this is pi square r to the power 4 h square. So if this is pi r h square, no, this is pi r h square. So I can write this as so I can write this as pi r h square plus r square. So I can write this as r square h square as pi square r square plus h square. One minute. So 3 into 3 pi 1 by 3 pi square into h cube. So r square h to the power 4 minus minus this is h, no, 1 minute, is a mistake is here. See here. So v is 1 by 3. So you need c square. So this is h square plus r square. If I need c square, that would be pi square r square h square plus r square whole square. Okay, so this is c square. Now this v is 1 by 3 pi r square h. So v square will be pi square r to the power 4 h square by 9. Okay. Now what I need 3 pi h cube vh cube 3 pi vh cube minus c square h square minus c square h square plus 9v square plus 9v square plus 9v square. So 3 pi v 1 by 3 pi r square h into h cube minus c cube. H, this is h square, and then c is pi square r square h square plus r square whole square plus 9v square v square, that is pi square r to the power 4 h square by 9. So 3 get cancelled. 3 get cancelled. This is pi square so this is pi square r square h to the power 4. This get cancelled. This is plus pi square This is pi square r to the power 4 h square minus h square pi square r square into h square plus r square whole square. Now if you take common here, so pi square r square h square, so you get r square plus h square minus pi square r square h square small mistake happened. This is pi r square h square. This will be h square plus r square. So this will be equal to 0. You need to understand here that when you see this C is pi RL. So when you see C is pi RL, where what is L? L is slant height. L is equal to h square plus r square. So this is pi r root of h square plus r square. So if you do the squaring of that, you'll get this. So if you do the squaring of that, you'll get this. Okay, now here this will be this. Fine. This would be this. And so this will give you the answer called 0. So the answer for this problem will be 0. Fine. So these all questions which I thought to discuss in this chapter, uh, where we talked about the volume and surface area of solid figures. So before this, I have done around 3 sessions where I discussed lot of problems. Around 70 problems I have solved already on area, perimeter, volume, surface area. All these I have discussed around 70 questions already before conducting these sessions. So I hope you will go through those sessions if you have not gone through till now. So it will be good practice for you at the time when you're preparing for UPSC exam. So I think you can understand many exams. I think simultaneously when you're preparing for UPSC, you would be also preparing for SSC or IBPS or any other exam, RRB, any other exam. So you can understand the amount of correlation in the portion of all these exams. When I talk about quantitative aptitude section, so you can understand how by working on one topic, you can prepare yourself simultaneously on many topics. So the important thing here is to understand the concept and to solve as many numericals as you can. So please do not miss the previous videos on the concepts based questions related to area, volume, surface area, and and perimeter. Based on them, already I have covered a lot of questions on the chapter on mensuration. Please do not miss those questions. So I hope you like my class. So if you like my class, please click on the like button and please subscribe to my channel if you have not subscribed. With that intention, I like to say goodbye to all of you. Thank you everyone. God bless you. Bye.